What's up, everyone? Buckle up for a new episode of Tech in Check. Let's dive into the basics and complexities of machinery maintenance with engineers Rich Marriage and Tony Planamento. Join us as we meet with guests from the marine and industrial world to learn about the latest technology that keeps your equipment in check and working for you.
Hello, my name is Rich Marriage, and I'm here with Eric from Vulkan. I can't pronounce your last name, man. I wasn't even going to try.
Dutch, the Leeuw van Weenen.
Yeah, see? All right, so there we go. Eric, you, tell us a little about yourself, introduce yourself, and thank you for coming, by the way.
Yeah, thank you for having me. Eric, I'm the Director of Business Development at American Vulkan Corporation,
Okay.
USA. I run the sales department together with the outside sales.
Right.
And I try to do the marketing, which is a challenge. But been here 11 years now. Moved to the US in 2011.
In 2011, you moved to the U.S.
Yeah.
And what was your background prior to that? Are you
my
an
background is
engineer
I'm a mechanical engineer.
So you are mechanical.
Yeah.
And where were you educated? In Holland?
In Holland, yeah.
Okay.
I did general mechanical engineering. Started working at Damen shipyards.
Oh, okay. I didn't know that.
So, on the purchasing side, actually, instead of the sales.
Ah, interesting. So you know both sides.
Yes, I know ships very well. My dad was a captain on a dredge. So I said I don't want ever anything to do with shipping or boats. And,
Here you are. You can't help it.
It's in the blood, right?
I know. I have the same problem.
Yeah. So 16 years ago, I transitioned from the purchasing side of things to sales side to
Interesting.
Vulkan in the Netherlands. And like I said, 11 years, I ended up here.
That's excellent. And you're in how do you like the States? How do you like living in the States?
It's different.
It's different.
It's a good life, though.
I like Holland. I like your country a lot, and I like your beer.
Me too.
Anyway, let me moving on. Tell me a little bit about Vulkan. Describe how the company started, how it's grown. Like, what's the history of Vulkan, and what industries do you serve? Now, I believe you're the marine side, but you do.
I do several things. Yeah.
Okay.
So, Vulkan is a German company, a family-owned German company.
Okay.
Close to Düsseldorf. 135 years old.
Wow.
They were
That's nothing.
That's pretty old. First they did like gears and stuff, and then slowly transitioned into the flexible couplings.
Also, they were a gear manufacturer initially.
Yeah, did all kinds of other stuff before we made couplings.
Was the company name always Vulkan? Did they?
Yeah.
Okay. So even as a gear manufacturer, they were Vulkan.
Vulkan Couplings und Getriebebau. So Getriebe is gears. Right?
Yeah, Getriebe is gears. Yes.
It's in the name.
Zahn, isn't Zahn the
That's
gear
a tooth? Yeah.
Yeah, gear tooth.
Yeah, correct. So, American Vulkan is celebrating their 50th this year.
Well, that's respectable.
In the U.S.
Okay.
So that's pretty impressive. And
Yeah.
we've grown a lot. We're close to 100 people now.
Here in the U.S.
In the U.S.
And as a whole, the company's pretty large.
Yeah, we have offices all around the world. So we have 5 manufacturing plants, which is the U.S., Brazil, India, China, and Germany.
Oh, wow.
So
5 locations doing manufacturing. So the
and
manufacturing's not just Germany.
No, correct.
That's interesting. Yeah. Okay, good. Now I know I can say, hey, come on. I need the product. I need the product.
It comes from all over the world.
And what industries do you serve?
So Vulkan has 3 divisions.
Yeah.
Most people know it from the marine stuff, couplings.
Right. That's
so
right.
the flexible couplings, resilient mounts, composite shafting, stuff like that.
Right.
We have another division called Drive Tech, which is industrial products.
Okay.
So jaw couplings for pumps, for example.
Yeah.
Backstops for conveyor belts, fluid couplings.
Oh, I didn't know you did backstops.
Any type of brake for industrial applications, or for cranes or whatever.
Driveline components, rotating machinery.
But industrial side.
Okay.
And then the third one is, it's called lock ring, which is a compression fit for ACs and refrigeration systems. Instead of brazing it, it's a compression fit.
Which is a nice thing to do
So we
for
have
installation.
Yeah, and we have a lot of OEM customers that use that on their
Okay.
products.
And you guys invented that product.
Well, not sure if we invented it or bought it.
Is that a U.S. exclusive product, or was that something in Germany?
We sell it globally.
Okay.
Yeah.
Was it developed here?
We make it here though. So in the U.S., we actually produce those. It's a little ring,
Yeah.
and we make millions of them. But we actually make them in our office here in Winter Haven.
Oh, that's good. So American manufacturing. That's kind of
Yep.
nice.
Yep.
That's good. That's good to hear. I'm familiar with Vulkan, couplings for this in two categories that I'm familiar with: misalignment couplings and torsional couplings, and then of course the combination of both.
Yeah.
So maybe you
in
could give us a little bit of
a lot of people, especially in the yacht industry, it seems the yacht owners don't even
Yeah.
realize that they have a flexible coupling in their
I
system
know.
because it's typically hidden in the driveline, but it's there. So there's three main functions for a coupling,
Mhm.
right? So one is the vibrations, the torsional vibrations, take care of that. Alignment or misalignment, if you will.
Okay.
And then it can act as a fuse. So
For shock.
for shock, you hit a log or something, or you run aground,
Right.
the coupling will break, and,
Right.
then it protects the engine from breaking down, which is way more expensive.
Yeah. So I'd like you to elaborate a little bit about torsional vibration and why it's so critical to isolate that and to
Right. So we do the
So
torsional
you're
vibration analysis.
damping it.
Yes.
Right. Damping it.
Yeah. Correct.
Not eliminating, but damping it.
We dampen it. Yeah.
Yes.
So the rubber basically dampens the vibrations in the system, heating up the rubber.
Yeah.
So it converts that torsional energy into heat,
Right.
basically.
Yeah.
So what we do, we do that here in Winter Haven. We do the torsional vibration analysis
Right.
for the whole driveline.
Right.
So we check that all components are within spec, so that the stresses in the crankshaft, in the gears, in the prop shaft, and are below the limits. So
And-
then we can fine tune that with picking the right coupling, the right rubber stiffness, etc.
Right. And that's really, really important. You can't
Very
just
important.
throw a coupling on a piece of machinery. You really need to make sure it's tuned
Yes,
to that system.
very important because there's a big chance of failure, bearing failure, gear failure.
I
crankshaft
remember going to the Deutsches Museum in Munich,
failure, right?
and I saw a model. They had a model that the Germans built back in the late 1800s, early 19. And I guess when they started going with reciprocating engines, that's when the problems really started with torsional vibration.
Yeah.
Am I right about that?
Yeah.
And-
Well, a lot of people don't realize, if you look at an engine, it just spins perfectly, right?
yeah, exactly.
But it doesn't. It actually, every explosion is a
Acceleration.
It's acceleration. So it actually doesn't spin nice and smooth. So that's where
No.
we come in. We take care of all those little
Yeah.
shocks and torsionals. And
Yeah, they help.
we make
It
sure
makes
that
a big
it runs
difference.
smooth.
So, the rubber stretches like a rubber band.
Yep.
Every time you get an acceleration, it absorbs that shock a little bit and it helps to smooth
It
it out.
actually really twists. You can't really see in operation,
Yeah.
but it actually does that.
Yes, with that camera I was telling you about, the high-speed video, you can see that.
Yeah.
And then you could slow down the motion.
It's
So
really
it's kind of interesting to visually see it.
Yeah, absolutely.
But torsional vibration can be very damaging and harmful. I remember reading in World War II, they were having crankshaft failures on the airplanes.
Yes,
Because,
it happens. The stresses can be crazy,
yeah.
and
Yeah.
a lot
And
of
they're
people don't
cycling.
realize that.
So it's fatigue, right? You get
Yes.
like a fatigue
Yeah,
failure.
it's like a sinus wave,
Yeah. So torsional vibration, and then the other thing I was going to mention is when you have like with the modern noise control and with the engines being on resilient mounts, you also have to have that misalignment coupling,
Yes.
right?
Correct. So that's the other thing we do. We do the mounts.
Yeah.
So we do what's called the 6 degrees of freedom calculations.
Yeah, exactly.
To check that the mount doesn't get into resonance areas with the
The
engine,
natural
the
frequencies.
natural frequencies, and because of that resilient mount, the engine is able to move left, right, up, all
Yeah.
6 degrees of movement.
Yeah.
So that means the flywheel will be moving.
Mhm.
So we have specific couplings for that can absorb all that movement of the engines
Yeah.
to the gearbox. So
Yeah. Well, that's
great.
one of the things I've seen in our business,
Yeah.
troubleshooting these problems is like, if they go cheap on the coupling, and they don't have a coupling that can absorb the misalignment,
you'll have issues.
then you're putting a lot of stress, and you have an engine on resilient mounts and the machinery on resilient. They have to be compatible. You have to have the amount of right. You have to be able to allow the movement
and the connecting components too.
Yeah.
Sometimes we see a beautiful engine on resilient mounts and the coupling, and then they hot mount the piping. That don't work.
Or a hydraulic pump.
Correct.
They'll have a PTO off the other end
Correct.
of the engine. That's like,
Yeah.
what were they thinking?
People are still learning how to do that. It's
It's crazy, yeah.
And we can help and advise, just like you do,
Yeah.
with your customers, how to
Right.
do it right.
I think people forget, like they just get focused on one part, and they forget that the whole thing is a system, and they need to
It's a
consider
system.
everything.
Correct.
Yeah. So yeah, it's interesting. I mean, and you have some excellent couplings for misalignment and torsional combined,
Yes.
like the Rado the Rado R and
Yeah.
the Rado S,
Yeah.
right, are very good for that.
Yeah. So the R is a ring coupling, and the S is usually the bigger coupling, the
Right,
big stuff, and
right.
big gensets like we have on the cruise vessels.
And the S stands for segment.
So the coupling consists of segments,
Yeah,
so you can easily take it apart in a small space, and,
Yeah.
it makes it easier to handle in the engine room because it gets too heavy and too big.
I see. I
So
didn't
with
know
the,
that.
with the segment pieces, it's easier in a
That makes
small
sense.
space. You can take the segment out and take it out of the engine room. If it would be one big piece ring,
Yeah.
you can't do that.
It's hard for maintenance. Yeah.
Yeah.
So the torsional character, I always thought the Rado S was more flexible and more
Not
torsionally-
necessarily,
but it's
No.
it's the segment is more on the maintenance side
Yeah.
than it is for the flexibility.
Yeah, and it's just size and weight. So
Yeah.
typically, on that big size, you're talking 8,000, 10,000 kW.
They get massive.
Yeah, they get big.
You make some big couplings, huh? What's the
Yeah.
biggest coupling you've made?
I think it's close to 1,000 kilonewton meter, but 7 feet diameter.
7 foot in diameter. That's massive. That's a big coupling.
Heavy.
Yeah, and then what you do, again, I'm not the expert, so, but from what I recall, you start connecting multiple, like you put more than one row.
Depending on what properties you need torsionally, we can have 1 row, or 2 rows, or 3 rows, or 4 rows
Yeah,
to make it stiffer or softer. So
Right.
we can play with that, and then we can also play with the rubber mixtures. So the stiffness of the rubber or silicone, if needed. Silicone is
very flexible.
it's
right?
flexible, but has different properties than rubber. So silicone acts differently. So on low load, it's very soft.
Ah,
On high load, full load, it's sometimes actually stiffer than the rubber. So especially in smaller gears, that works great.
Yeah.
With gear rattle,
yeah,
and it has better resistance against high temperatures. So in the bell housing, it
Wow.
works great.
so silicon sounds like that's good rubber mix for
It
what
can
you
be,
do.
yeah, it can
Huh.
be.
Silicon. And the other thing is you also have that feature like on the icebreakers, right? That if something would happen, like because of a shock, and something happens
Yeah,
to the
so-
coupling, then
so
you
we-
have these safety
Yeah,
devices.
we call it a TLD, torsional limit device.
Yeah,
So in case something fails and you're out in the ocean, you still want to get home.
right.
So it's basically blocks of steel mounted on the coupling
Right.
that would connect when the
Right.
rubber is broken.
Right.
So it runs steel to steel, so you can only run it like 10% load, but at least
Yeah.
you can get home
Yeah.
instead of being lost at sea.
We've had 2 recent incidences where we had a customer that, he had a fairly large pleasure yacht, and the torsional coupling had failed, and you could see with a bore scope. It was a close coupled unit,
Right.
and he was out there running this thing at full speed, like you're going to destroy your
Yes,
your
that-
engine.
you don't want to do that because that will damage the gear and the
Oh
engine.
yeah, it's terrible.
Bad idea.
Yeah.
Bad idea.
Then we have another boat, like you were talking, like this the couplings are almost like forgotten
Yes.
because they're
They're kind of hidden often
on the
yachts.
coupling
It's close coupled
guards
that
and-
you can't see them. So because it's natural rubber,
yeah,
it gets old
It has a
and
life.
it gets harder and brittle, if you
Yeah.
will. So it needs maintenance.
Yeah.
So
Yeah.
just like with the Brazilian mounts, same. It's natural rubber. So after about 10 years or an X amount of running hours, depending on the model of the coupling,
Yeah.
you have to replace it.
Yeah.
It might look great, but properties have changed,
Yeah.
and it could break.
it's
by surprise.
We've
You
had
don't
them,
want that.
we've had them fail. We've
Yes.
had to do emergency where we've flown out to, and you and your team probably as well. Where you fly out and have to change the coupling in like some. We had to do this in the Bahamas. We
Yes.
flew to the Bahamas, had to separate the gear and the engine and change out the coupling. A big job to do in a remote location.
Yeah. We have 6 service engineers now
Yeah,
that work with you guys.
Yeah.
I know they do on yachts. But
Yeah, you
they
guys have
fly
the
all,
lasers
they
and the
fly all over
vibration.
the world
Yeah.
to help. We work on U.S. Navy vessels
right.
where they only allow U.S. citizens to work on the boats.
Oh wow,
So they sometimes fly to the other side of the world to work on a coupling.
wow. Yeah, it's a big issue.
Yeah.
It's but it's this one boat, there's a fairly large yacht. It wasn't in their maintenance plan to inspect or service the
And
coupling.
it's in the manual. Every
It's-
coupling we supply, a manual,
Yeah.
and it clearly states that. But I guess people
Yeah,
don't read.
People, I don't know if they don't understand, they don't think about it. Like, and the engine and gear guys, the problem is you got the guys that repair the gears, you got the guys that repair the engines, and that's the connecting.
Yeah, and
piece.
it's a simple,
And it gets
relatively
overlooked.
cheap part.
It gets overlooked.
They forget.
Yeah. And there's you guys, I know, like everybody else, has been supply chain, disruptions and getting parts from Europe is not. So, we're trying to, make sure people think about this.
Yeah, it's very important.
Yeah.
We try to keep. We have about $9-10 million in inventory
Right.
in our office here in Florida.
Yeah, it's awesome.
But
You guys have a good.
it's
inventory.
always a challenge because there's so many different
The
models
variations.
and variations
I know.
that you can't keep everything in stock. So we try. Germany has a lot too, so
Yeah.
we can fly stuff in.
Yeah.
It gets expensive though with the
And
logistics
then you have
nowadays.
the, rubber, getting rubber, and then they got to mold the rubber
Yep.
and then vulcanize it and
Vulcanize,
whatever they
right.
do. It's interesting process, right? They take the rubber comes from like Africa a lot of times, right?
Asia,
Asia
yeah.
and Africa,
It's a natural rubber. yeah.
Brazil,
From the
right?
trees.
Some Brazil.
does.
Yeah, and it's natural rubber. I mean, it comes from
With
trees.
The war affected our steel supply actually.
Oh,
So
no kidding! The war in
So
Ukraine.
yeah.
Wow, that's crazy.
So it's
No.
a different world.
Yeah, it's a different world. Yeah, and steel is that's another part of the coupling. The
Right.
steel, and then and the rubber, and then I remember hearing that rubber trees have had a fungus problem, and
That happened a few years ago. We had that.
yeah, I mean it's interesting,
Nothing you can do. Just
Yeah.
drives up the cost. And
Yeah,
there's nothing
and I
you
mean
can
you
do.
think about all the rubber components in the world,
It's a
tires
lot.
on cars and couplings, and this. I mean,
It's crazy.
and it's all coming from a tree.
Yeah.
It's kind of
Right.
crazy. It's like you forget about that. Even at this level, there was sophisticated culture.
It looks the
Still
product.
making
The end
things
product
from
looks
trees.
simple, but there's a lot that goes in
Yeah,
it.
yeah. So, is there any new products on the horizon? Is there anything you want to talk about, like the Torel? I know you have that monitoring system, for example.
Yeah, we have a monitoring MDS system, which is a pretty basic system that it measures the angles between the input and output,
Okay.
and if it's off within the limits, then
Right.
you'll get a signal. And
Okay.
you can use that signal to throttle down or clutch out or whatever.
Mm-hmm.
We're gonna have the SMM show in Hamburg coming up. One
Yeah.
of the biggest marine shows in the world.
That's
I think,
this year,
this year in September.
September.
We're going to present some new stuff where
Oh.
we're working on a new design shaft. It's kind of a, let's say, coupling composite shaft in one, if you will.
Oh,
It's
interesting.
Pretty new development.
Okay.
We're working on some bigger size couplings that, within the existing known models, but then
Right.
going up in size.
Okay.
Working on shock mounts. So that's one of the things we do, shock mounts for Navy vessels.
Yes.
So
yeah.
when a ship gets hit by a bomb or mine,
Yeah.
all the equipment on those Navy vessels are set up on shock mounts. So
Right.
they can take all that energy and reduce it so that the equipment doesn't get damaged.
Yeah.
In Europe, NATO has come out with new rules, stricter rules. So we're developing new big shock mounts
Huh.
to take that load.
Interesting.
So that's a whole new development we're
Huh.
doing. So there's plenty going
I guess I better not say, stay away from politics.
on. Yeah.
Stay away from politics. But that sounds interesting. So that's going to be so this year in Hamburg, there's going to be some big news.
They're
from
going to
Vulkan.
present that.
Okay, good.
There's some other small stuff that they're doing in the background.
Yeah. And how's in general? We're touching on industry news. Is there any new regulations or requirements that have specifically impacted Vulkan? Is there anything?
Not so much regulations, but what you see it now that hybrid is a big thing, right?
Yeah.
So thinking about that could affect our business, because if everything goes electric,
Yeah.
people don't need a coupling anymore,
As
right?
much, right? You still
As
need
much.
a coupling for
Yeah,
alignment.
alignment, but not necessarily maybe a
The
real
torsional.
torsional coupling. So what we're doing is something called hybrid architect, where we almost act like a consultant,
Huh.
where we can help you design a whole system,
Oh, driveline.
the whole drive line,
Oh.
specifically for the application needed. It could be fully electric, diesel electric,
I see.
all kinds of combinations. So that's a change in our business model.
Interesting.
They're going
You gotta adapt.
They're going to have that at the show too in Hamburg. Yeah, we have to adapt to
You
the
have to
world.
adapt. Yeah, you have to adapt.
Yeah. And then the other thing we see is fuels.
Okay.
Yeah,
I was just about to ask you about that.
they're going to go to
how
all
is-
these ammonia fuels.
all these
and
different
LNG.
fuels. How does that affect the torsional?
They change the torsionals. They do. So we're trying to keep up and see what it does and what the effects are and what we might have to do
to adjust for that.
adjust for that.
Like the hydrogen, ammonia,
Yeah, the engines react different.
LNG.
Yeah.
The engines behave differently. I think
Yeah.
from what I saw with the LNG, for example, the vessel I was on had they used diesel as a pilot fuel, so they're still using diesel. Like so, the injector would have the diesel come through the
Yeah.
center, but then the gas around the outside. And I guess they got a more even burn that way.
Yeah, that's how I understand
Yeah,
it too.
yeah. But I mean, like I would think that
But it changes the way
LNG would be
the
more
pulses are.
torsional. I think
Yes,
more
so we see
torsionally
differences
live
there.
and active.
Yeah.
And that's
So we-
probably
We try to investigate
Yeah.
and keep up with that, run those torsionals and see what it does for us. you
Yeah.
know, so we can advise customers basically, oh no, you need a bigger coupling or a different type of
Mhm.
coupling.
hmm Yeah, one of the things that we're expanding on as well, talking about my company a little bit, we're doing more torsional vibration measurements.
Yeah.
To be able to get those, to see what's happening, with
And that's important. A lot of people forget that.
yeah,
Like retrofits.
yeah,
They just throw something in there and oh, that's how we did it in the past.
No.
Well, it's just a little bit different and now
Yeah.
it doesn't work anymore.
right. Things are
So
changing.
that's very important to do that.
yeah.
Hey guys, we're reaching like a 5 to 10 minute mark, I would say max. Where are we
Okay.
at on the outline?
We're almost there, right?
Yeah.
Where are we
So
at?
I'm on 5.
Okay, so we're near the end.
I'm on the end.
Okay,
I'm on the end.
perfect.
And a lot of this stuff I already discussed actually.
More or less,
Okay.
right? Yeah.
Because right now we're at probably 25 minutes with the 10 minutes before that's great.
So, and again, in our experience, like, where do you guys see like things go sideways with couplings? I can tell you from what I
Problems, you mean?
yeah, like I can tell you what we see, but I mean,
Right.
I'd be interested in what you think, and then I'll add something at the end.
It comes back to what we talked about already. One is a TVA. A lot of customers don't do a TVA
At the beginning.
at the beginning,
Okay.
beforehand,
Right.
and they just use whatever they used before, but something changed,
Mm-hmm.
and then all of a sudden they have a problem.
Right. Right.
We can help with doing a TVA. We'll throw it in for free if needed
Yeah.
up front. So you
Yeah.
prevent a lot of really costly changes, especially if it's a close coupled system and you got to take that apart in the engine room. That's not a fun job.
No.
So if you do that right up front,
Yeah.
you avoid that problem.
What I noticed too is I've had you guys do some TVA for me, and one of the things I noticed is you have a vast database of machinery, because one of the things that I found, it's very difficult sometimes to get the details
Yes,
from the engine. Like you need piston, connecting rods,
Correct.
crankshaft. You need a lot of detail
Yeah.
that a lot of manufacturers are not willing to share.
Correct. We have good connections to all
Yeah.
major engine suppliers.
Yeah. Which is a big value.
because they're customers too.
Yeah.
So it's really important to have the right data. Otherwise, you cannot do the TVA.
And they trust you, and it's in their interest
yes.
to have their engine working properly.
Yeah, it protects their
It
equipment.
protects
also.
them as well. So they, so this TVAs. But what I've seen, from my side, we come in a lot of times we're on the back end after we're doing troubleshooting and diagnostics after it's been in service.
Yeah.
And what we see is sometimes we see faulty installations, and we see misalignment, and people not taking into account mount creep and the fact that the mounts settle over time.
Correct.
But the one thing that I see a lot, which is very, not a lot, but we see that people neglect to check the axial control distance
Yes.
between the coupling and
that's
the
a very important point, because if it's off, you're going to create a force on the bearings, either on the
Yeah.
gearbox side
a thrust
or
force.
or the engine, and it will take out the bearing,
Yeah.
and that gets really expensive.
Yes. So the installation is that's where our company comes in, and new construction and refits is we do alignment and laser alignment, and then we do commissioning vibration surveys, and we can even do the torsional analysis.
Yeah.
And I know you offer that as well. I know. But this axial control
Very important,
distance,
right? And it seems that the shipyards might not have the same qualified people as they used to.
yeah.
I mean, it's a lot of people don't want to be in this.
The thing is, there's companies that are more specialized.
So that's where you get in, and where we get in
Exactly.
to help them do that.
You got these specialists that know the equipment. And I think it's a liability issue, and things have gotten more complex. When you talk about shipbuilding, when I first started in yachting, a lot of the machinery wasn't even resiliently mounted. It was all hard mounted.
Yeah.
And torsional coupling, it wasn't, the horsepowers was so low, a lot of times it wasn't even an issue. But now you got high horsepowers, you got noise control features that, have to be very carefully adjusted and paid attention to.
Right.
And, all that stuff is critical.
And small engines are putting out double or more the power
Yeah.
in the same small block.
And they're a lot more
it's causing
torsional.
a lot more torsionals.
A lot more torsionally live, yes. More power, more firing pressures per cylinder, yes.
So
Yes.
we have specific solutions for that too. We
Yeah.
come in with weird inertias that we got to fudge into the
Yeah.
bell housing, but
Yeah.
that's solutions. For
It's
that.
it's very complex and interesting field, and it all comes together at the end, to have a quality engineered
Smooth
product and
running.
a smooth running vessel. You really need Vulkan. You need people like Vulkan to do that for you.
Absolutely.
And those the other thing I noticed that I wanted to bring into attention is on the mounts. The mounts
right
here. They need to be adjusted occasionally.
Correct, because
And
they
the
have
buffers,
creep.
the snubbers need adjusting as well. We've
Correct.
seen where they're bottomed out and they're not adjusted. And you want to talk a little about that, maybe?
Yeah, so same mounts are made out of natural rubber, so they have creep
Yeah,
just because of the load and the movement.
exactly.
They have an internal buffer, so that limits the movement.
Yeah.
In ocean, it's a class requirement. You got to check that opening, the gap.
Mm-hmm.
Otherwise, that snubber is going to be hitting the foundation,
Yeah.
and it loses the whole function. It's going to be noisy and it's going to create vibrations.
Yeah.
So after the first install, like half a year later, you want to
Yeah.
recheck that, realign that a little bit.
Exactly.
It's not very difficult. We have a height adjustment nut for that integrated on the
Right.
mounts. So you just have to realign that a little bit. But you have to check it every year. You got to
Yeah.
check that alignment and that gap, the snubber gap.
So it's not something. It's we're a maintenance engineering company, and and that's what I'm trying to point out to people that
Yeah, it's very
you got to
important.
pay attention to these things.
Very important.
It's not something you can just blindly forget.
Yeah.
Otherwise, you could find yourself in the middle of the ocean, broken down with no propulsion.
Yeah.
So these are all important things, and I want to thank you for your time
Well, thank you
and
for having
coming
me.
by to see me in my shop here.
Yeah, we love working with
And
you guys.
it's a pleasure. I really enjoy our relationship, and I thank you for
Well, thank you.
being
you very much.
working with
Yeah.
me.
Thanks for listening in. We hope you enjoyed our deep dive into this week's tips and tricks for equipment optimization. Want to learn more? Head over to AME's LinkedIn, Facebook, Instagram, or YouTube included in the show notes, along with details from this episode. That's all for now, folks. See you next time.